Good evening, everyone. Welcome to the Aquarium. I'm Jerry Schubel, president of the Aquarium, and it's great to see all of you here this evening. Before we start, I want to acknowledge our sponsor, Gazette Newspapers, who makes it possible for us to have this lecture series. Our speaker this evening, LuAnn Dahlman, is part of the Communications and Education Group at NOAA's Climate Program Office, and she develops climate-related educational materials. She spent a season at McMurdo Station in Antarctica, and she'll be talking about that. She was working with an international group of scientists and drillers, gathering insights into our changing climate by looking at cores, both through the ice and through the sedimentary rocks. And LuAnn was a former high school science teacher, and she has focused her attention on enabling teachers and students to use innovative technology to investigate scientific data and tell scientific stories that are consistent with those data. She has had a big impact on this institution. She was instrumental in helping us design the exhibit on the Arctic and the Antarctic. She was very instrumental in the film that we created on the Arctic and the Antarctic. And in the last issue of Currents magazine, she had a big role to play in helping with that article. She grew up in Mesa, Arizona, graduated from Arizona State University with a major in geology, and I guess a minor in education, or at least enough education to be certified. She taught high school for a number of years, and then went to that other university in Arizona, University of Arizona, and she taught there for 7 years. She was mostly teaching teachers how to teach science, and then she went from there to a place in Cambridge, Massachusetts that's called TURC. They do innovative things in teaching and learning. And then she went with NOAA, and she's been with NOAA for 3 years. And today, is it today your anniversary? So her 3-year anniversary with NOAA today. And we work closely with NOAA, including their climate office, and I can tell you that she has had a big impact on that office. She's one of the few people I know who has been able to, for 19 years, work remotely and convince her bosses thousands of miles away that she's actually doing something. That's interesting. I have to come to work 7 days a week to convince my boss. Please welcome LuAnn Dahlman.
Thank you very, very much. That was nice. It's true, when I was in Antarctica, I kept telling people, oh yeah, I work from my home in Arizona. No one knows I'm down here. So this is just a little intro slide, but I'm going to actually, do I have a clicker from away from this, or do I just need to use my computer?
We'll get you one. Maybe you can start.
I'll do just fine here. A little overview about what we're going to talk about. We're going to actually start with a story in Minnesota, and then we're going to get some background on Antarctica's ice, what it's like to work there, the climate secrets, and then some of the education products that we've come up with. First of all, any other Antarcticans in the audience? Just 1, 2? Okay, yeah, it's a fine place to have been. Will that require a USB? I'll just go ahead and get started. So this story starts with a boy named Charlie. It's I'll just do it. I apologize. Okay, boy named Charlie, and they had an annual 4th of July picnic. Every summer they went, and he got together with the grandparents and the aunts and the uncles and the cousins, and they ate. And he noticed that they always loved to argue about the weather. They sometimes fought about it. They remembered it differently. He was a practical kid, and he thought, I'm going to solve this problem. I'm going to keep a weather log. I'm going to write it down every day. And so I'll be able to solve the problems. But 11-year-old kids in the summer, it didn't last very long. And so by the next year, when he came back to the next picnic, people asked him, what about that weather log, Charlie? He said, gosh, I had to give it up. But again, he was very practical, and he thought, well, I'll just keep the track of the weather for the 4th of July each year. And so he did. Year in and year out, along with the food and the fireworks and the fun and the fights about weather, he kept marking down the weather. After about 10 years, he developed a few other interests, but he was still marking down the weather. After 20 years, he'd actually started his own family, and he was noticing that some of his relatives are getting a little older, but still marking down the weather. Finally, the year that Charlie turned 40 years old, he entered his 30th entry in the July 4th weather logbook. And he started to feel like he had a pretty good sense of what it was like on the 4th of July. Thought he could talk about if it was warmer than normal or cooler than normal. Started getting a good sense. Matter of fact, he took a look at his record book, and it looked something like this, with the high and the low. He also had other things written down. These are just the temperatures. And he noticed that some years it was pretty cold, other years it was downright hot. But he wondered if he could come up with a way to say what it was really like. And he decided that an average of the minimums and the maximums gave him a pretty good idea. Thought, yeah, that feels about right. So he put those two on a graph, the high and the low, and he said, yep, in between those, that's kind of the normal range of the day. He also knew that some days, some years, the temperatures were higher. The highest temperature in 1982 was up at 95, and this was higher. He also knew that it was sometimes lower. But he also knew that that was just 1 year, and that this, between the red and the blue, described something a little different. Matter of fact, he found out that he could get those high and low temperatures for every day of the year. Now I'm going to tell you that Charlie's a fictitious character, but what he discovered is real. And what the real deal here is climate. These are called climate normals, the average high and average low for every day of the year in a certain location. And they're calculated over 30 years. So these normals, here they are for the first 10 days in July, and you can actually look at them for Minneapolis for the whole year. You can see it's cold in the winters, January, up to the high in July, and then down again. Now the reason I'm showing you this is one of the things I get to do is work with software developers on cool tools to help people understand climate and weather. And this one happens to be from Minneapolis. The green range here is the exact same graph as I just showed with the red and blue. But it shows the normal climate normals, temperature, this being the high and this being the low. And then what it does is plots the weather over it as an overlay. Some newspapers actually show this kind of a thing in the daily paper. But this tool allows you to squeeze it so that you can look at more days at a time. And you can start to see the patterns just from the graphics. You can see there were a few days that it was cooler than normal. That's after some of warmer than normal. And you can continue squeezing it so you can see a whole year of data at a time. And you can talk about weather versus climate. Actually put this together so we could just take a quick look at Long Beach as well. And you guys have had a little bit below normal, just the West Coast modulates your weather pretty well, though. But over the past year, a lot of it's been below normal. You can see some of the green above. So one of the reasons that I want people to understand the difference between weather and climate is so that they don't think that climate change means that every year the blue bars are going to be a little higher on the green. That's just not how it works. Instead, if we have it really squeezed down, climate change is actually when the green part changes, when 30 years of data averaged over that time comes and makes a different shape than it did for this 30-year period. As a matter of fact, the last decade just ended, and so they have just released new climate normals. And across every state, all of them are warmer. The minimums are the ones that have raised the most. So the bottom of the green graph is going up, and then the top is going up a little bit less. Those have just come out in the past couple months, so they're not in this tool yet, but soon we'll be able to take that and do a graphic comparison between the old climate normals and the new climate normals. So my goal is to help people understand the difference between climate and weather, and that we can see climate changing. Questions about those graphs or climate or weather? Yes?
Is the 30 years mathematical or traditional?
Traditional, thank you. And sometimes people are using dynamic normals now. They'll just take 10 years and say, compared to the last 10 years, this is this way. But it's always an average over a certain period of time. Yes?
Is there any explanation of why around the Great Lakes there's more, it's warmer than anywhere else in the United States?
I don't know a scientifically published answer for that. I would surmise it has something to do with water's heat capacity, its ability to absorb heat without getting much warmer. We'll see some of that in a little bit. Anybody else? Okay, we can always go back to those. I'm going to jump in and talk about what I came to talk about, and that is some climate research in Antarctica. I went down there with the ANDRIL project, Antarctic Geologic Drilling. We did not really care about ice. We went right through the ice. Instead, we were looking at rocks. It was an international project, so I got an opportunity to work with people from different countries. And these people cared enough about science education that they brought science educators, 1, 2, 3 from the United States, 1 from New Zealand, 1 from Germany, and 1 from Italy. So it was a nice little international group of teachers. I put Turk up here to thank them. I worked for them at that time, and they allowed me to take off and go work with these folks. I learned when you're going to talk about Antarctica, be sure you show penguins. So here's Seth that wandered up by the airfield one day, and they are just plain comical to watch them walk. They're also very unafraid of people. Their predators are in the water, so they really don't care. Okay, so it's an icy continent. There's no question about that. But it's not just one kind of ice. But the ice is practically everywhere. If we dropped ourselves any place in the center of the continent, the view we'd see would be something like this. Mountains buried up to their necks in snow and ice, and it's got a flow pattern to it. And if you see it in some places, you can see that it's moving downhill under the force of gravity. And it's moving all the time. This kind of ice started life as snow and compacted to form glaciers that grew together and covered the entire continent. These are called ice sheets, and there's one on East Antarctica, and there's one on West Antarctica. That's the one we have to watch, by the way. Where these ice sheets flow down and go out over the water, they look something like this. It's still freshwater ice that landed as snow and came out and floats on top of the water. But they're huge. It has 8/9 of it below the water line and 1/9 above. And so you can see how thick it is. Here's one more shot of an ice shelf with Erebus in the background, the local live volcano. So this is where the large ice shelves are floating. And there's one more kind of ice. When the air above water gets so cold, the water freezes. Even seawater that's salty, it has to get a little bit colder than fresh water. But where you have choppy water and it freezes, it makes these pancake ice. If it keeps freezing, it can freeze solid. This gets more like about 1 meter thick. And this is the wake of an icebreaker that went through. Or sometimes it gets thick enough you can even do things like land airplanes on it. Makes a nice flat surface. And the sea ice runway in McMurdo is a popular thing because it's right there next to town. However, they watch it pretty carefully. This melt area they know pretty well when they need to stop landing planes on that because it'll soon be open water. So the sea ice is a little different than the Arctic sea ice. The Arctic has no land underneath it, and Antarctica has a bunch of land, but this ice forms all the way around it. In the summer, this is the minimum amount, and in the winter, it gets quite large. It's different because in Antarctica, a huge expanse forms and melts every year, not to be confused with the Arctic, where there's one core that kind of grows and gets smaller, but it continues getting smaller. And one reason it's so cold in Antarctica, it's not just because it's at the poles, but plate tectonics has told us that 150 million years ago, all the continents were together. This was called Gondwana, and it was still located here near the South Pole, but with a lot of land around it, it wasn't as cold. But over time, as the other continents moved away from it, isolating it at the bottom, this last little thing, as soon as this took off, this moved away, and that allowed water to start going around the continent like this, isolating it from the other continents, and effectively cutting off its source of any heat. This is South America, and just like in North America, how the Gulf Stream goes north, the warm water goes from the equator down, and it might get to Antarctica, but it's deflected by this current that goes around Antarctica. And that happens in every one of the oceans. So it's effectively insulated and remains cold. Not to say as water warms up here that it won't ever warm up, but it stays colder. Okay, so we have established it's an icy place. It's got all kinds of ice. And why does that matter to us? Right here at sea level, I'm hopeful that everybody in the room knows. There's a lot of water tied up as ice down there. And if it turns to liquid, it's going right in that same ocean we look out on. What we do know about climate is that humans have made a significant change in our atmosphere. This shows the carbon dioxide. And we've actually increased carbon dioxide by 40% from pre-industrial times, a significant change. We also know that Earth's average temperature is rising. Here's all the ocean heat content, the amount of heat energy in the ocean. We know that those things are going up. By the way, I'm just going to stop and say, this is another one of those cool software gadgets that I get to fool with by working at NOAA. This is on a site called climate.gov, and it shows 14 different climate parameters, just like the dashboard of your car. We're also turning it into a little app, so it's pretty fun. What we don't know, however, is how the ice sheets are going to respond to a warmer world. As one of the papers that was used in the IPCC report on climate change, they basically said, we're not sure what's going to happen. And geologists have a motto, and it is, the past is the key to the future. And so they said, well, if it's been that warm in the past, let's go there and see what it was like. Then let's see how it reacted in the past so that we can tell how it will react in the future. So we went there, and I'm going to go pretty fast. I'm going to tell you a little bit about what it was like to be working in Antarctica. The very first stop on the way there is the CDC. Some people think that's the Center for Disease Control, but it's the Clothing Distribution Center, where you stop and you get your parkas, all sorts of layers of clothes, innerwear, outerwear, gloves, hats, mittens, scarves, you name it. You send your measurements ahead to them, and they give you 2 bags of extreme cold weather gear that you got to take with you any place you go. They put you on a C-17. It's kind of like a military plane. As an afterthought, they put a few seats in it. It's like a cargo plane. And they take you down 5 hours from New Zealand to McMurdo Station. They only have 4 teeny teeny tiny little windows, but the view out of them gets pretty good. So, and you arrive in Antarctica. Emily, are you sure that's not you?
Might have been.
Nothing like you're standing inside the plane and they open the door and your first breath of Antarctic air. It's already breathtaking, and then you breathe deeper and it freezes your lungs. And so my arrival picture is right there. I saw it out there as well. But the funny thing about this, my mouth is pretty much frozen into that smile. It's like, it's pretty exciting. One of the very first things they do is want to make sure that you will be able to survive in case you're away from town. And so they send you to something called Happy Camper School. And it was one of the stormiest days of my entire trip. So you hike a long way, you're layered up in all your gear. You put up tents. You saw blocks of snow out of the ground, just like in cartoons, how they always saw blocks. And we built little fences out of those. And they made us sleep outdoors in Antarctica on the ice. But I lived through it, and to tell the tale clearly. Most of my days, however, were spent right in McMurdo. And it's a McMurdo Station, also known as Mactown. It's originally started in the 1950s as a naval base. There's the galley, there are dormitories, there's a lumber yard, there's the main science Crary lab on 3 levels here. It's got everything that a community has. It has only about 200 people, 200 to 300 people in the winter who winter over through the dark, and then up to 1,200 people in the summer. A lot of scientists coming through doing different projects down there, and mostly they're there to support the scientists. It is the land of midnight sun, and so that's looking to the south, where you would have expected the sun to dip, but it just went around all day long. I'm from Arizona, where everything's on a grid, and so I'm used to having landmarks and stuff, but you've got the sun going around you, and every place south is someplace, and the directions are really challenging. Straight south toward the South Pole is almost the exact same as grid north. And then they have this sundial that was always pretty cool. I couldn't help myself. I needed a picture of the midnight shadow. One of the vestiges of it being a naval base, they still have 24-hour clocks around. I never could get used to reading these. It's another cool clock that they have in the galley. All the numbers around the edge are an N for north, because every direction from the center is north. We always like to say, yeah, I was on the north coast of Antarctica. That would be the whole thing. I lived in a dormitory, ate in a cafeteria every day. The ubiquitous blue trays. We used them for everything. They were always, couldn't get away from them. Became friends with the chef, the mid-rats chef, Midnight Rations, and so got some great tours of some of the kitchen things that they did. A lot of interns go to Antarctica for their baking or other chef duties, and they come back and they've had this experience of cooking for 1,200 people. Lots of great tours of the kitchen. There's a greenhouse there, but it's only experimental. It makes only enough to add a little bit of greenery to some of the lettuce. Energy-wise, it's actually cheaper to fly in anything that you can grow than it is to grow it in the greenhouse. There's no soil allowed to be imported on the continent, so they grow it in this kind of medium, and it's just kind of sitting there growing. A little scary. All the hard goods that come to Antarctica, the vehicles, the parts for vehicles, the lumber, the building materials, the computers, all come in one ship per year. Every year you get one container. And all the science projects and their research equipment that will be coming for the next year arrive by then. So it's a real logistics almost a nightmare to get everything together a whole year ahead of time, get it into the container, get it onto the ship, get it down to Antarctica, and then you arrive a full year later and open up your container. Sure hope you packed well, because some people don't always get everything they need. Vehicles in Antarctica are pretty unique. All of them have a very wide wheelbase. That's because they need to run over cracks in the ice. Once they get something down there, even when it's an antique, they want to keep it there and keep it going. So they have a really big machine shop and motor pool to keep all these things in running order. It's all about having enough wheelbase to cross cracks. These are the coolest, and it's just like driving a truck, but there you are, 4 little bulldozer tracks. And of course, the ubiquitous skidoos. There are no dogs in Antarctica. They removed all of them that they used to use, like huskies, because they were afraid the seals might catch a virus from them. They also have all the things that it takes to run a community, the utilities, waste management, spiritual needs. A lot of people did yoga in the church there. It's a beautiful chapel called Our Lady of the Snows. A coffee house, a wine bar. This is actually in one of those old Quonset kinds of buildings. A real bar. I always thought, why do people line up to get into it? It's broad daylight. But it turns out this is the only place you could ever go and order food. It became something interesting to want to sit down and think about what you wanted to eat before it was served to you, instead of go to the cafeteria again and what will I serve myself. They had a station store filled with plenty of stuff, but limited selections. They had a barber right after a fresh haircut. And the recreation department put on a whole series of different things. They had a lot of people who did travel logs, because a lot of the people that worked there would travel in the off season, and then they'd come back and give slideshows and such. Different dancing, exercise classes, you name it, you could find it going on. It's a small town. The recreation department also checks out musical instruments. People would get together and play. Getting together to play was fine, but you couldn't always find a place to play. These are my 2 friends that love to play the violins, but they had to go to the electrical shop to do so. We also had some neighbors down there. The New Zealand base, Scott base, is just across the peninsula. And they put on some crazy parties. Every year they have a beach party, and we really do play volleyball and pretend it's a beach, briefly. They also have a skirt party. There's actually, the rule is you can't get in without a skirt. There's actually a long history of dressing up as women in Antarctica. The Scott team and things like that had a lot of putting on plays and such. They also have a friendly rugby tournament every year. They call it friendly, but someone usually goes to the hospital. So. They also give a couple of opportunities for people to get out on a field trip, just to get out and see the scenery beyond the town. This is the glacier in the front with the Mount Erebus in the background. An opportunity to see plenty of wildlife when you're out. These are Adelie penguins, Weddell seals. The funniest thing, they couldn't care less if you walk right up to them. You're not allowed to, of course. You're not supposed to interfere with the wildlife. That's part of the Antarctic Treaty. But they just couldn't be less concerned about you being around them. They're just take a quick look. The historic huts. You can still walk into the huts where Scott and Shackleton had set up research operations. And they ask you not to touch things, but there's no one there, or there's no rope in front of you to keep you from feeling like you're really there. So it's really an incredible experience. And this was very cool. You have to know somebody that knows where to find Ernest Shackleton's signature inside the hut. But he's quite the character. And so I was quite pleased to find it. Just a couple more things. The Big Red parkas. It's like seeing someone's car in a parking lot. You know they're still in the building if their parka is there, because you just don't go out without it. There I am with it on, red nose and all. And you always kept things with it. Big pockets allowed you to take whatever you needed with you. My favorite thing to keep in my pockets were, yes, tap shoes. I actually founded that tap dance class. I said, I used to go tap dancing, I'll try it out. And I went to it and had so much fun. I ordered a pair of tap shoes off the internet. They arrived in Antarctica in only 8 days, which goes to show they've got one heck of a supply chain. And I danced with people. We did it in the laundry room. You always have to look for places to do things there, but that was one of the only places with a large enough area on the floor. But we tap danced or practiced. I even ended up performing in a little soiree. So that's tap dancing in Antarctica, one of the last things I expected to do, but one of the things I enjoyed the most. So I've just given you a little overview. That's what it was like in town. It's like living in a small town. It's a lot like summer camp. However, a lot of people come to Antarctica and do research projects that are out in the field. They get dropped off by a helicopter, put up a tent, and they don't see anyone else for the next 3 weeks. They do radio in to say, yeah, we're okay, but they are out there for the duration, and they go do their hikes, and if they need help, they can reach someone by radio. But don't know this particular group, but we've always surmised that this person had an issue with snoring. But you can see they can choose a pretty incredible view for where to live, but sleeping on ice, I'm not so sure. They also have a lot of other really innovative projects. My friend Betsy was a part of this one, where they do a trek across the entire continent. Every 3 days or so, they'd stop and do a bunch of measurements. She would actually have to get out with that balloon, pack an instrument pack, and put it up there, and unwind the winch for a kilometer-long leash that she would take this instrument up there. She called it walking the dog. Gotta get out, walk the dog. Put it up there for a kilometer and bring it back down again. In between that, she had to sit down and dig holes in the snow and sample snow. So this is really an incredible thing when educators get the opportunity to go and do these sorts of things and see. It's important to be exposed to the tedium of those sorts of things, and then to see the results come out. Another educator friend that I have has made a really great life for herself. 3 months a year she lives in this tent, but she looks out at this. You may not be able to tell, but this is a penguin rookery. You can see the groups of penguins down here, and just off the view of this is Shackleton's hut. This is at Cape Royds in Antarctica. And she does the education for a bunch of folks who are doing penguin population studies. And so she facilitates a way for students around the world to watch on her website, and they choose a breeding pair of penguins, and then they do things like predict their egg laying dates and predict how many eggs and when they'll hatch and those sorts of things. And she gets to sit in her tent with binoculars and look for the ones that have been tagged and write down what they do and share that. It's hard to convince her she doesn't have the best job in the whole world. She's pretty sure she does. Did anyone want to ask questions about living? And living should have quotes around it. Visiting in Antarctica. Yes?
When you guys were all out there, like you said some didn't see anybody, did polar bears come to those areas?
Polar bears do not live in Antarctica. That's an Arctic animal only. And there are no predators for humans in Antarctica. Just humans.
What animals are there predators of each other?
There are seals that eat penguins, tiger seals, leopard seals, I'm sorry. One of those cat names. But humans only have each other to worry about. Yes? The planes come in about twice a week during high summer season. And so you can bring freshies in, that's what they call them, you know, milk, eggs, vegetables, fruits. But canned goods and things, frozen foods, dehydrated foods, the industrial, institutional strength food comes on the container ship. Yes.
I have two questions. One, what is the source of the water that's used? Like you showed the laundry room, obviously that takes water. The other one is, how is waste disposed of?
Thanks for both of those questions. The first one is, all the fresh water is produced with reverse osmosis. People keep telling us that you can't desalinate the ocean. Well, you can, but it's very expensive. And so it takes a lot of energy, but they force seawater through a series of filters and use energy to desalinate ocean water for the water. And the other question was about waste disposal. I showed the recycling. You had to sort your trash into 7 different bins, and they recycle 70% of the material, somehow use it again, or send it back on the empty ship. But nothing goes to waste there. They watch it to the letter. There were safety trainings that I had to take. There were also waste management briefings that you have to take, where you sit down and you do the class online and such, so you know how to handle those things. Yes?
What's the energy source there? You have a power plant?
Yes, once upon a time, there was a nuclear reactor in McMurdo Station. The folks at Greenpeace thought that was a horrible thing to do to that pristine continent, and so they came down and parked the boat there and protested, and sure enough, people gave in, and so now we burn oil. There are huge oil tanks, and electricity is generated from burning oil, which leads to climate problems with exhaust from oil landing on snow, darkening it, therefore it absorbs more heat from us. Yes?
Are there earthquakes down there?
I didn't ever feel one. I'm not sure about how many. We did have a team of structural geologists that know all about the faults that are around there, but not so much.
I'm just talking about what I know.
Yeah. There you go.
Layman's.
Is there another one back there?
What about human waste? How is that disposed of?
The power and water plant has, they actually, I don't know how to be delicate about it. It's just a regular sewer, and they evaporate water off of it. It's really weird because I was there once, and plants grow out of it, like from seeds and stuff. I'm like, what's going on? It's really weird. But again, they take everything back off the continent. And one more, yes.
Who's the government there? When you say that, they give training, they do this, they do that, they tell you to do this or that, who's they?
It's a great question. Thank you very much. The National Science Foundation runs the United States Antarctic Program, and they're the ones that set the rules for that research station. They also run the research station at the South Pole and at Palmer Station on the Antarctic Peninsula. But Antarctica itself, a lot of countries have research stations there, and they run their own programs. But it's all under the auspices of the Antarctic Treaty, which is a number of nations that got together and said, let's save this continent for science. And so there's still some political maneuvering, and everybody says nobody owns it, but there are still maps that the CIA has that show the pie-shaped pieces that different countries have claimed for themselves. So we're working together on that.
What's the age of the ice when they do a core drilling?
The oldest one that they've ever reached is 800,000. More commonly at Vostok, that's in the center of the East Antarctic, 400,000 years is another one. But it depends on how deep and if you get to the right place. The 800,000 year one, I'm not exactly certain exactly where that's from. Sipple Dome, perhaps. But it depends on where you can get the drilling done. And then have the last question.
What's the greatest hazard for humans there?
think I ever felt at risk. That's when you're out, let's say in a helicopter, you could crash, and if you don't have supplies, but they make you take everything with you. I mean, every lunch that you take, even on a field trip, was like a half bag of groceries, because they always want to make sure you have enough. And you're always in radio contact and things like that. So it's about being isolated from people. But they go to a lot of lengths to make sure people are safe. We're finally going to talk about that research. This is why we went down there, so how we study past climates. And we're just going to start by talking about the opportunist's view. If you're an opportunist and you want to study past climates, you go to some place where nature has laid things out for you, like the Grand Canyon. That river moved through the canyon and took out all the stuff and has just exposed the different environments that laid down different types of rocks over time. And we can see it right there. So we can have plenty of years of history laid right out. However, if you want to find out the history of some place like Antarctica, it's a little bit harder. First of all, you got the ice in the way. And second of all, the ice is moving. The ice is going downhill, and it happens to be taking rocks with it. This came out just in the past month in research. Someone has made a new map of Antarctica that shows all the ice streams, the ways that it's flowing off the continent. And they have the whole continent here. The colors here show the different speeds of the ice. But you can see that there's a whole area that drains to one area. This is just like a watershed map for another continent, but it's ice. The point here is that the ice is moving downhill slowly, and at the base of that ice, it's grinding against the rocks, and it freezes the rocks into the ice, and it scrapes it down, and the ice is busy taking all the good rocks off the continent. So where it's actually taking them to is right here around the edges of the continent. As a matter of fact, this would be a really great place to find out what rocks have been taken off the continent and what types of environments they've been deposited into. You might think, well, why don't you just take one of those drilling ships out that goes around drilling the ocean floor and do that? You know, go right up to the continent and do that. Well, that little thing of the sea ice. As a matter of fact, a lot of ships got stuck in sea ice, and sea ice will actually grow and squeeze ships and break them down. So you can't really get there in a ship. So the folks on this project had to invent something new and innovative to get to where they wanted. This is where they wanted to get the sediments. And so, but this ice shelf was in the way. This is not to scale, but it's a nice illustration. It's about 100 meters, or a football field worth of ice here. And then about 800 meters of water. And what they did is put a drill rig up here, and then put a pipe through the ice. They just blasted hot water through it to get the pipe through, and then went down to do the drilling. They had to invent something up here in order to keep this pipe from sticking to the ice, however, from freezing to it. They put a reamer, this thing that went on the outside of the pipe, and it went up and down in there, shooting hot water out to keep the ice from freezing to it. The reason that was important is this is actually moving at about a ½ meter per day. And it's going up and down every day with the tides. So they had a serious engineering challenge, and were able to overcome that, put this down in here, and recover over 1 kilometer of rock core. In order to do that, they had to pack it all up a year early, and then at the very beginning of the season, while it was still winter there, had to bring out about 12 containers worth of research equipment, put up this drill and this custom-made tent that went over it, kind of like one of those special event tents to keep the weather off of it. This is looking up inside of the tent. And this is the business end of a drill. This just goes right down into the ground, and it's industrial strength diamonds, and it just grinds around and around, and the rock that goes up in the center is the rock core that we gathered and took out of there. Drilling is really all about adding pipes to the top of that drill bit. You just keep adding another pipe on top of it and pushing it down, down, down with the drill, and then pulling up what comes up in the center of it. The drillers, very funny people. They're all from New Zealand. They just love to say what they think when they think it. You never heard so many jokes about drilling in your life. They did love to talk about drilling, but they let anybody drive that drill. Every time they brought up a section of core, they treated it like they just had a baby. They measured it, they cleaned it off, they described it, they took care of it, and then they cut it into 1 meter lengths so that you could actually maneuver it. They were pretty big around at first, and so a meter worth of rock was good and heavy. Later on, as the hole got deeper, they end up going inside the last pipes, and so at the end you get these little toy cores. But you take the cut cores into town, and you take them right to the core cutting van, where they get cut again. This is actually where I did a lot of my work. A lot of it was documenting. You had to write everything down 4 times, not once, not twice, 4 times, to have proper labels on things, and then cut the core right down the middle so that you'd open it up and see the insides of it. Clean that off. So it wasn't just to see what's inside, but one of the core halves became a working half that we'd work with, and the other one was put away, the archive half. So we still have a pristine record of the core that was drilled. It's kind of like a box of chocolates. You never know what you're going to get when you open them up, but some of the cores were just absolutely beautiful. I'm going to talk about what we're seeing here in a minute. The core got a lot of attention. There was a whole night shift of 12 sedimentologists who would go through the core centimeter by centimeter to describe what they found, what kind of rock, the textures, what it meant about the environment that was present when those rocks were deposited. Scientists would listen, and they all wanted their own piece of the core. They're all looking for different things. Some people were looking for microfossils. Other people were looking for the shape of certain rocks to tell where they were from or the composition. So after people put their flags in where they wanted, then the curators would cut the core apart with more sample bags and labels and distribute those to the scientists for their research. And they did all sorts of other research on them. Chemistry on some of the pore water, paleomagnetism to tell the age of the core, looking for microfossils, diatoms, a lot of diatomists in Antarctica. And what did we learn by doing this? This is one of those, if I push it twice, I know it's going to... I knew it. Okay. In really cold times, ice piles up so much on Antarctica that it expands out off of the continent right onto the ocean floor. So much ice, so much of the seawater is turned into snow that sea level goes down and ice goes up and it comes all the way off the floor or across the ocean floor. When it does that, if you were at the place that we later drilled, you have this ice sheet coming off the continent, and it's just grinding right over the ground. It's picking up pieces of rock into the base of it and just kind of running over it, scraping it. And that produces a certain kind of rock. Big angular chunks of rock, all unmixed, unsorted, but just kind of put together. And so when we see this kind of rock, we know that there was a glacier here. That's what deposits that sort of rock. Likewise, as things started warming up after that, and water gets underneath the edges of the ice sheet, it melts from the bottom up. So you end up with a big ice shelf and icebergs. And if you were at the place where the drill was, as a matter of fact, this is the environment that we were drilling in. But this is moving downhill, and it's putting out a lot of rock material right here. And when this gets too steep, it has a sudden landslide underwater, and all the things settle out. And so you get some layers of rocks here. You also get some rocks that were still embedded in the base of this that are dropping out and drop to the bottom. So you can get some drop stones within the rocks. And so when we see layered rocks with drop stones, we can say, this was an ice shelf environment. One more environment, if all the ice on the water melted, then phytoplankton can grow. If they have sunlight to get the energy, they can grow here. And they grow and they blossom. That just means they have a really proliferate. And then they die, and their skeletons rain down to the bottom like rain and make this ooze of dead sea critters. So the top of the water is green here, showing that they're photosynthesizing. But when they die, by the gazillions, they fall and you make layers of this. So that's what this rock looks like, diatomite, almost all fossils. And so what we found is repeated sequences of those rocks. It was cold, then it warmed up. And we found over 50 cycles of the ice advancing and retreating in the past 14 million years. Now you're like, well, what does that mean for us? They're big numbers, but what it means is that the ice sheet reacts dynamically. It responds to changes in global temperature. It's not just going to stay the same size for 35 million more years. We have evidence that it has been changing on a pretty regular basis. As a matter of fact, by now the project is old enough that we've been published in all sorts of great places, Nature, Science, Geology, those sorts of things. I'm just going to point out one result that they point out here. Results show that over the past 5 million years, this was a more specific study, West Antarctic ice sheet transitioned between full, intermediate, and collapsed states in just a few thousand years. This means that the ice sheet is likely to disintegrate if ocean temperatures in the ocean rise 5 degrees. I'm almost certain that's what it says. Yeah, rise by 5 degrees Celsius. So, again, what they're pointing out is we have evidence. The way the ice sheets will respond is badly. They're likely to respond and melt and raise sea level. This project is ongoing. It's run through University of Nebraska-Lincoln. They still have a lot of, they're starting with a new drilling hole in the next year at a place called Coleman High. Any questions about that? Because I'm about to transition, I apologize. Yes?
Yeah, I'm kind of thinking that what's down there under the water is sort of like an underwater moraine, that it's a conglomeration of different sizes of material, and finally, maybe down deeper, a sort of sedimentary conglomerate rock. Am I thinking right, or?
Yeah, what I described as the unmixed, or I'm sorry, unsorted with large angular fragments.
Yeah.
It's actually called diamictite, or in moraines are the same thing. They're formed by glaciers. So pushing all that rock and crumbling it up and leaving it below it.
But eventually they get so compacted that those drill cores that we saw were hard rock, not just
It's true. It's true. All these sediments are lithified. They've been turned compacted into rock. So, but that they did start life as looser sediments. Yes.
Are there researchers cross-referencing the times when the ice sheets had melted with geological data from, say, like North America or another country, like to see where the water was when those warm periods, like where there were fossils?
There's a huge amount of discussion or debate in the scientific community about northern hemisphere, southern hemisphere. So, of course, everybody that's doing their research wants to correlate it with other places on the world. I can't point to a specific one that has found things to tie it, but one of the major goals of Andril was to give more data for the southern hemisphere, because most of our global climate models are based on everything in the northern hemisphere. After all, that's where most of the land is, most of the people are, and we just have less data from the southern hemisphere. Not sure that was very satisfying. But yes?
Is oil aggregating in the fossil material?
We did not find any evidence of anything that someone would classify even near petroleum. A lot of people were concerned that's what we were looking for, but it's not true. Yes?
In all those, like this 50 you mentioned.
Cycles.
Have they found any of those that would be comparable to what's happening to us now?
I don't really have a good answer for that. The one I would point to is just, it said that it went from the full state to the collapsed state within 1,000 years. So.
I wanted you to give me an answer. It says it's okay. It's
No.
They don't know.
Okay, I'm going to wrap things up pretty quickly here. I just want to show you a quick thing, quick couple of things. From this experience, what I do is generate learning materials. And I put together a set of 15 hands-on activities that what I like about them is it gives the learners a chance to be the teachers. I hope I've captured this in what I'm going to show you. One of the activities, there are some postcards, and you get little factoids on them. But it allows students to learn the factoids and then share them with people, kind of transferring postcards around. There's also an activity that has 10 separate maps, and it works on map reading skills, and then they have to describe to somebody else, what do you see here, and why is it? This is one of my favorites, actually, have them make a model of the Andril setup with rocks down here, water, ice shelf, and then the PVC pipe down the center is the drill. And it's pretty funny, kids know instinctively to walk up and they turn that thing and make noises. They get to build that whole thing. Too many kids don't get engineering opportunities, I think. And then they take these little paper cores and wrap those around, and then they actually pull little cores out of that thing too. So they can describe to people what kind of research was going on there. It's worked very, very well with 4-H groups and Boy Scouts and such across the nation. We also have a whole set of videos really focused on people. There's some real gems within these. We also put 5 banners together. They're museum quality banners, and they're in 6 languages because we did get some funding from the International Polar Year to do these. Some really good illustrations of just kind of the things we were just talking about. And putting it all together, Antarctica's climate history.
Is that
And
available?
Yes, those are on a website. You can download those
website.
or have them printed at Kinko's. I'm happy to share that info. I'll give you my card and I can email that to you. Last, maybe, I'm not sure, maybe least, there was also a NOVA video produced about this project. And it aired last year in December, but I saw when I went to this that it's about to air again in December. So if you are interested in that project, you can take a look at it. I'll just mention, just this month, the National Research Council came out with a study that they've just done, and there's still a lot to be done. Antarctica is, it's bigger than our United States. and a lot of stuff going on there, and it really will affect the rest of the planet. So we'll be doing science down there for a while. And that's what I have for you tonight.
We have time for a few more questions. Before we do, I want to make a comment that LuAnn has made major contributions to helping the general public understand what the advances in science are. We have this ongoing debate as to whether it's better for scientists to partner with people like LuAnn, who knows how to translate and disseminate scientific information to the general public, or whether it's better to try to make scientists into communicators. I'm in the camp of having partnerships. There are some scientists who are outstanding scientists who are good at communicating with the public, but they are a small minority, and that is not where you get your rewards in research organizations. You get promoted and tenured because of the number of publications you have, the amount of grant support you bring in, and the number of graduate students you have, and not for giving the greatest talk to the public or creating videos. And so I think these partnerships are really, really key, and you've done a great service. Yes, over here.
Oh, you talked about East and West Antarctica. What makes something East and West in the Antarctica?
Could everyone hear what makes something East and West in Antarctica?
It's based on where the prime meridian is that they decided to call one East and one West. Everything's north from the south.
Kind of arbitrary.
Yeah.
So, I wanted to say, you were talking about the difference between weather and climate. As he often was, I think Mark Twain had it right when he said, climate is what you expect and weather is what you get.
Yeah.
Anybody else have a question or a comment? Yes, go ahead. Nice and loud.
Did the researchers who started the drilling project, or the engineers, did they do any research on the sound pollution produced by the drilling and its effects on local cetacean populations?
They certainly had to address it. So they must have found that it wasn't a factor, because everything that's done in Antarctica requires that you do a study first so you don't mess things up for somebody else.
Other questions or comments? Don?
Since it's at the pole, I would expect that the magnetic field strength is greater there than it is in the middle of the Atlantic, for example. So I just wondered if they got enough information on the magnetic polarity of the iron samples in the sediment to know how many times that's reversed in the last 800,000 years.
They actually used the paleomagnetic record matched against how often the Earth's magnetic field flips to constrain the ages. And then they checked that against the fossil record, the diatoms, and it was right on. That field has really matured, and they can tell a lot just from if you have a long sequence of undisturbed sediments, and you can check the magnetic recording for each one. You can have a good constraint on age.
And so I think everybody knows the poles have reversed throughout geologic time. What north became south, south became north. Any other one? We'll take one more. Yes, go ahead.
How active is that volcano down there?
How active is that volcano?
It has a lava lake in it, and it's. I hear all sorts of wild and crazy things about it. They've been doing some very interesting experiments on it as well, imaging right through the mountain. People have that kind of classic, they draw a picture of a volcano and they say, and here's the magma chamber under it. But nobody really knows what that looks like. But the configuration of Erebus is such that they could go through and do some imaging around the outside of it, and so they're getting a better picture of that. It steams all day long. And in our core, there were certainly ashes of different volcanoes that had erupted, but it appears to not be a point of concern for people.
Well, we're going to continue our partnership with Noah and LuAnn, and I'm sure she'll be back. LuAnn, thank you very much for a wonderful lecture.